I've received a couple of questions about this problem from the homework, and I didn't put this on the Google form, but I did want to work it in case you were interested. I'd prefer to do this on a board. It's difficult for me to type some of this up and to make slides because of the pictures that you're missing out of. But I'm going to try to talk you through this so that you could work these. If you're interested in doing more of these, this is actually in chapter 11. This is frequently taught in a multivariable calculus class, and so you will encounter this again, most likely in your math or physics careers. What I'm going to discuss is finding, and maybe not exactly this particular problem, but these ideas. So we're going to find the area of a parallelogram. Now, you are given 3 points, P, Q, and R. In 3 dimensions, in dimensional space, so imagine space out in front of you, if you were to throw up 3 points in midair, then when you connect those 3 points, you could of course form a triangle. We don't know what type of a triangle is it. We're asked what type of a triangle it is here, but what we're going to do is find the area of that triangle, and you could actually do this using cross product. And I included this problem. We've worked law of sines and law of cosines problems. You could go that route, but actually in 3D, then the cross product, the magnitude of the cross product, gives you the area of a parallelogram whose sides are given by 2 vectors, u and v, in this formula I have here. So what I'm going to do is find the parallelogram. So a parallelogram would have 4 points. I'm going to find the parallelogram formed from these 3 points. The other 4th point would make that 4th, would enclose the region. And since a triangle is half of a parallelogram, think of it, a triangle as half of a rectangle is a parallelogram, then I will find the 1/2 of the area of the parallelogram. So to get started, these 3 points, this is kind of hard to imagine since I have it drawn on 2D right here, but these 3 points I could connect and form a triangle. I just want to find 2 vectors that represent sides. So imagine a parallelogram with 4 points here. Maybe the 4th point would be down here. I want to create a parallelogram, so you'll notice the parallel sides whose sides are bounded by vectors. And so if you were to go from, say, I'm going to go from Q to P right now. So if you were to go from Q to P, what is your overall x change? You would have gone from the value, and you could imagine a number line, a one-dimensional number line right now. So the x value went from -2 to x equals 1. That means your x value increased 3. So for u, I'm going to use an x change of 3. The y went from -7 to 1, so that's a total change of 8. And from -1 to 1, that's a total change of 2. I'm then going to find vector v, which will go from q to r. So what I'm doing here is finding qp and qr, and those would be the sides of this parallelogram. -2 to -7, oh, well, that was a change of -5. -7 to -1 is a positive change of 6. -1 to 4 is a positive change of 5. So if you'll notice what I'm doing there is I'm finding the change for each of those coordinates. Once you've found that, go ahead and pause the video, and from my assignments you should know how to find the cross product now. So I have given you a formula, and you can also use the matrix form. So go ahead, pause, I'll pause with you, we'll find the cross product. Great, hopefully you took some time to do that. When I worked it myself, I have that u cross v is equal to 28i. So I'm going to put this, use the pointy brackets. 28 was my horizontal component, -25 was my component along the y-axis, and then 58 would be vertical. That would be 28i minus 25j plus 58k. The magnitude of that, so what you do to find the magnitude is you take the square root of each of those components squared. So 28 squared plus 25 squared plus 58 squared. And then you take the square root of that. That's how you take the absolute value. When you do that, you will get, so I recommend using a calculator. I know you won't like those values. Those are difficult values. So just just from working it out ahead of time, I did get the square root of 4,773. That is not your answer, because this is the area of the parallelogram. That would be if this were enclosed by those 4. So if the sides were all made of those vectors. We want the triangle, we want half of that, so that is why D would be your final answer.